Hey guys, welcome to this channel. In this video, I'll give you a high level overview of all the different container services that you can use on AWS. So, if you have not subscribed to this channel yet, then subscribe so that such informative videos can reach to you quickly. If you want to run a containerized application on AWS, you have multiple options to choose from depending on your application requirement. So, we will go through all these options one by one. We will see what ECS Elastic Container Service is and what it is used for. Then we will compare it and talk about EKS, which is Elastic Kubernetes Service. We will also see different way of running containers with EC2 or AWS Fargate. And finally, we will see the ECR Service, which stand for Elastic Container Registry. Now, think about a microservice application scenario. If you are developing microservices, you would need containers for each, and containers scale pretty quickly. Maybe you create replicas, you have different third party services and applications for your microservice application. This could be messaging, systems, authentication services, etc. So you end up with a bunch of containers that you need to deploy on some environment. In this case, we are talking about AWS Virtual Service. So let's say we have created 10 containers for each our 10 microservices. Plus, we have 5 other containers that our microservices use which run different applications. And let's say we deploy all of this on our EC2 instances which have Docker installed on them. Now, once you have deployed them, how do you manage them? So, you have an infrastructure of all these virtual services that are running all your Docker containers. How do you know how much resources you still have remaining on this machine? How do you know where to schedule the next container? How do you know by looking across your infrastructure whether some of your Docker containers are not running anymore, whether servers ran out of resources, and when you see that some containers have died? Do you manually restart each container? If you have maybe 5 replicas of one application container you don't need anymore, how do you get rid of all those containers? Do you stop them and remove them one by one? And these are all things that you need to manage when you have tens of containers, maybe hundred of containers that you need to manage on your infrastructure. So obviously you need some kind of automation, some kind of tools that can help you with all these issues, and all these things that I manage that I just mentioned are features of a container orchestration tool. So you probably already know one of them, which is the most popular orchestration tool, which is Kubernetes. But of course, there are multiple orchestration tools out there. Docker Swarm is one of them, which is for less complex, a bit smaller containerized application. You also have Mesos Apache. You also have HashiCorp Nomad. And you also have an AWS service called Amazon Elastic Container Service, which is ECS. So ECS is one of the container service that AWS offers, and it is essentially a container orchestration service. So, ECS, being an orchestration for containers, will manage the whole life cycle of a container. When you start the container, if it need to get rescheduled somewhere, if it's need to get restarted, load balance, etc. So how does this service actually work on AWS? If you wanted to create a cluster, a container cluster basically, that is managed by AWS ECS service, you would create an ECS cluster, and that ECS cluster will basically contain all the services that are necessary for managing the individual containers. So ECS cluster basically represents a control plane for all your virtual machines that are running containers, and that control plane and the managing service in that control plane then can manage these individual containers, and essentially managing the whole life cycle of a container from being started scheduled to being removed. When you create ECS cluster, as I said, you have the control plane, but the containers need to run somewhere, right? So containers need to run on actual machine, on virtual machine. So where do this virtual machine come from? This virtual machine will be the EC2 instances. We would create an EC2 instance that will basically host the containers. The EC2 will not be isolated and managed by us completely, but EC2 instance will be connected to this EC2 cluster that we created, and on those EC2 instances you will have the Docker runtime or container runtime generally. So that containers can run, and also you are going to have ECS agents installed, and this the control panel or ECS processes can communicate with each individual EC2 instance and manage them. So at the end, it means that you have a control plane that helps you to manage all your containers and automate some of these complex things that you don't want to do manually and repeatedly. So you have delegated the management of your containers to an AWS services, so you don't have to worry about that. However, you still have to manage the actual virtual machines, the EC2 instances, meaning you have to create the EC2 instances, you have to join them to ECS cluster, and when you schedule a new container, you have to make sure that you have enough EC2 instances and resources. To schedule new container, you also have to manage the server operating system, and you also have Docker runtime and the ECS agent, as I mentioned. So all these are basically part of a virtual machine that you have to still manage. On the upside, of course, you have full access to your infrastructure, which is an advantage. If you need full configuration, access, and power of the infrastructure, that's runtime your container. So now you have delegated the management of your containerized application or your container basically to the AWS service, which of course makes your operation easier. However, you still have the infrastructure to manage the virtual servers. Now, what if you wanted to delegate management of the infrastructure also to AWS? So, you want the container lifecycle to be managed by AWS, and you want the hosting infrastructure to also be managed by AWS. Now, there is an option for that, and it is called AWS Fargate. So, Fargate is basically an alternative to EC2 instances. So, instead of creating a provisioning EC2 instances and connecting that to the EC2 cluster, ECS cluster, you don't need to provision any virtual machines. You use Fargate interface, and Fargate will take care of spinning up the VM to run your container. So, how does Fargate work? Fargate is a serverless way to launch containers. So, you take a container that you want to deploy on AWS, and you tell AWS, here is my container, please run it, and you hand it over to Fargate. Now, at this point, you don't have any virtual machine that will run your container. You have not provisioned anything or any server yet. You just have the control plans of ECS, and you have the Fargate interface. So you give your container to Fargate and you say, please schedule this. Fargate will then take your container. It will analyze by looking at your container how much resources your container needs to run, how much CPU, how much RAM, how much storage it needs to be deployed and to run. And then Fargate will itself automatically provision a server resources for that specific container, and then it will deploy and run that container on the provision server resources. So this happens automatically, and every time you add or you hand over a new container to deploy to Fargate, Fargate will do the same. You go and provision server resources to run that specific container. So advantages are, obviously you don't need to worry about having enough EC2 instances and resources to schedule a new container, because you don't have to provision anything beforehand, and because you don't have to provision the infrastructure before you deploy containers. You always have only the amount of infrastructure resources needs to run your containers, and that means you pay only for the resources that your containers are actually consuming. And also it really easily scaling without fixed set of EC2 resources defined beforehand. Since every new container gets new resources, the pricing is based on how long the container runs and how much CPU and memory was requested for that container. So for comparison, for EC2, you obviously pay for the whole server, even though you might not be running any containers on it or just a few maybe. And for Fargate, you only pay for the resources that containers is consuming. So now you have your infrastructure managed by AWS using the Fargate service, and the containers that are running that was scheduled through Fargate are now also managed by ECS. So you have multiple levels of your infrastructure and the application on it being managed by AWS services. Now, the only thing that you have to worry about and manage is the actual application itself. So, you develop the application, you create containers, and that's it. And then you just deploy the containers on AWS infrastructure, which obviously is a great thing. However, again, if you need more access to the underlying infrastructure, you need access to the actual infrastructure running your containers. Then you have the flexibility and access with EC2 instances. And of course, when you run your containerized application on AWS infrastructure using the AWS service, you have advantage of using any other AWS services from the AWS ecosystem, right? So both EC2 and Fargate and ECS and all these services obviously fully integrated with the whole AWS ecosystem, right? So this could be CloudWatch for monitoring, Elastic Load Balancer for load balancing, IAM for permissions and user, VPC for networking, and so on. Now, this is how you can let AWS manage your containerized application using ECS. Now, what if you want to use Kubernetes? As you all know, Kubernetes is the most popular container orchestration tool currently. So, lots of projects, lots of companies actually use Kubernetes. So, can you still use AWS infrastructure if you want to use Kubernetes, and how can you use that? AWS actually has another service which is for managing Kubernetes cluster on AWS infrastructure. So, alternative to ECS, you have a service called EKS, which stands for Elastic Kubernetes Services, that lets you manage Kubernetes cluster. So the difference or advantage of using EKS is the first thing I just mentioned, which is if you are using Kubernetes already and your project wants to deploy their Kubernetes cluster on AWS infrastructure, obviously you want to be able to keep your Kubernetes tool and not use appropriate container orchestration of AWS. You have an option of doing that using EKS. So that's the first obvious reason. Another reason, if you do not necessarily think about using Kubernetes or you don't already use Kubernetes in your project, making decision between ECS and EKS is basically ECS is specific to AWS, right? So if you decide at some later point to migrate to another platform, you will not be able to move that cluster to another platform because it is really integrated and based on AWS with EKS through because it's managing the Kubernetes cluster. You can easily migrate Kubernetes because it's not specific to AWS, right? It's an independent tool which you can use anywhere. So you can migrate or much easily migrate Kubernetes cluster on another platform or maybe even on premises, right? If you have your own infrastructure in your company, then you can use the same configuration, same tools across multiple platforms. So that's a major advantage of using EKS versus ECS. Now I have to mention here that even though Kubernetes is an independent tool, if you using it on AWS and you use a lot of additional tools and services from the AWS ecosystem in your Kubernetes. Then, of course, when you migrate your Kubernetes cluster, you will have to replace those services with some other tools because they will not be able to own another platform, right? Because these services are again specific to AWS. So just know that it's not 100% easily migratable, especially if you are using AWS specific service in your cluster. So that's maybe one thing to consider. Another also important reason for using EKS versus ECS is that if you use Kubernetes, which is again a much more popular orchestration tool than ECS, you also have access to all the Kubernetes tools and plugins and things are developing in the Kubernetes ecosystem like Helm and some other tools that integrated well with Kubernetes. Now, on the side of ECS, a more suitable use case for ECS is if you have less complex containerized applications that maybe don't need this full-fledged Kubernetes cluster to run in. In this case, you can actually deploy it on ECS cluster, and also you don't pay for the ECS control plan compared to EKS cluster control plan. But generally, I think EKS is much better choice for managing and orchestrating your cluster on AWS infrastructure. Now, how does EKS work? It's actually pretty similar to how ECS works. With EKS, you create a cluster which represents the control plane in Kubernetes. Well, these are going to be the master nodes. So when you create an EKS service or EKS cluster, AWS will provision in the background Kubernetes master nodes that already have all the Kubernetes master services installed on them. So all of that is managed and provisioned for you. You don't have to worry about master nodes for your Kubernetes cluster. Also because it's managed by AWS, these master nodes, it will automatically replicate the master nodes across multiple availability zones. So if you are creating EKS in regional EU West 3 that has 3 availability zone, then you will get automatic replication of your master nodes on those AZS, and of course then you have the storage which is the etcd part of the master processes which stores the whole configuration, the current state basically of Kubernetes cluster, and that storage needs to be replicated and needs to be backed up because you shouldn't back up because you should not or you cannot lose that data, otherwise you will lose all your cluster configuration. And again, because it's a managed service, AWS will also take care of storing data it and backing it up properly. So basically, master nodes of Kubernetes is not you worry anymore. So with EKS, you have the master nodes control plane configured. Now you need the worker nodes, right? You need infrastructure that actually runs your containers. Again, same way as in the ECS, you will create EC2 instances, then so called compute fleet of multiple virtual servers, and then connect them to the EKS. And now you have the master nodes and worker nodes group connected, and that gives you a completely Kubernetes cluster. And once that's done, you can simply connect to the cluster using Kubernetes commands and start deploying containers inside that cluster. In the example of ECS, we show that this EC2 instances, this compute fleet, each server had the ECS agent installed. This way the control plane could communicate with the individual nodes. In this case, we are in the Kubernetes world. So worker nodes will have Kubernetes processes. So this way control plane or Kubernetes master node can communicate with worker nodes just like they do on any platform, right? It's not a specific to AWS is this case. So you have the worker nodes made out of EC2 instances that are connected to the EKS cluster. However, in this case also you need to manage the EC2 instances yourself. You have to manage the operating system and process is running on them in EKS cluster. However, you have a possibility to choose a semi-managed EC2 instances for your cluster. So basically, you can group your worker nodes into nodes group, and the node group can actually handle some of the heavy lifting for you and basically make it easier for you to configure new worker nodes for your cluster. For example, worker nodes or EC2 instances managed my nodes group will get all the processes necessary installed on them, so you don't have to worry about installing container runtime Kubernetes worker processes, etc. For them to make it into worker nodes. So that means you have an alternative between completely self-managed EC2 instances and semi-managed EC2 instances through nodes group. And when working with EKS, it is actually a good practice to use nodes group because they make lots of things simpler. Then you can also create multiple node group to group your worker nodes in different logical group. But as I said, it is still semi-managed. You still have to take care of some other stuff, for example auto scaling, right? You don't have the auto scaling configuration out of the box. You still need the configure things in Kubernetes. And on the AWS side, to make auto scaling possible, so you have to take care of creating new institute instances, removing them, etc. However, if that's also something you want to delegate to AWS, if you don't want to worry about that, you can also for EKS cluster use Fargate instead, and in that case you would have fully managed worker nodes in additional to fully managed control plane. So these are the three steps of worker node infrastructure management you have available in AWS. Or you can even use both EC2 and Fargate at the same time for the same EKS cluster. So basically from the hosting perspective of where your container are running, having EC2 and Fargate as alternative. This part is pretty much the same whether you use ECS or EKS, and this basically gives you the combination of the service that you have as an option if you want to run a containerized application on AWS using a container orchestration tool to manage them. Now we just saw two of the services on AWS that are specifically for containers, and this is one more container service on AWS, and that is Amazon ECR, which stand for Elastic Container Registry. So basically this is just a repository for container images alternative to Docker Hub or Nexus Docker repository, where you can store your Docker images. For example, advantage of using Elastic Container Registry is of course because it's part of the whole AWS ecosystem. It integrates well with other services. So for example, if you use EKS with EC2 instances, for example, then it will be easier to connect that and configure your cluster with ECR to fetch the instances, but also to do some other stuff like automatically get notified when a new version of the image gets pushed to the registry, and then automatically download that into your cluster, and also some other additional features. And of course you have all those abilities because these are all AWS services, so they are tightly integrated with each other, and ECR is pretty easy and straightforward to use. You basically create your private repository for your different application images or Docker images, and you can start pushing different version or different tags of that image to those registry, and then of course use that endpoint to download the images from the cluster. So to summarize, on AWS you have three container services. First, for storing container images in private container repository, and the other two for orchestrating or managing your complex containerized application on AWS infrastructure. And in this part we are gonna look at ECR and EK services and use them in our CI/CD pipeline to build and push images to ECR and deploy them to Elastic Kubernetes Service. So that's it for today, guys. If you found this video helpful, so share this video to your friend and like this video. If you new to this channel, then subscribe this channel and stay tuned for further video. So thank you for watching this video. Bye and have a nice day.